Hey everybody, ABC10 meteorologist Brenden Mincheff here with another look at the drought update. And there's been a little bit of a change to the map, but not a positive one. Now 26% of the state is in the extreme drought category, and that happened right here, kind of on the west side of the Sacramento Valley, starting to eke into those coastal ranges a little bit. But there is some rain and some snow on the way. Our next weather maker is just off the coast of Alaska, and it will be scooting in over the next couple of days, and it will bring all this rain, and some of that will be snow to northern California. Let's talk about how precipitation forms in these clouds, because it's going to lead to a highly requested topic. If we take a look inside of a cloud, we've got thousands upon thousands of these condensation nuclei. These could be anything like dust, could be dirt. If you've ever been to the Midwest when it rains, and then when that rain dries, sometimes it'll leave behind little watermarks, little really just little circles of dirt sometimes on cars. And that's because that's the condensation nuclei. That's that dirt getting kicked up into the air, helps make the rain. And then as that rain falls, the water dries, water evaporates, but the dirt is left behind. So that could be an example of condensation nuclei. It could be smoke, could be ash, anything like that. But what happens is if we take a look at just one nucleus, the water vapor in the cloud condenses around this nucleus. And when enough of it does that, we end up getting a raindrop or a snowflake. And this happens over and over and over again in the clouds, and that's what helps create, or what really serves to create, the precipitation that we see fall out of the sky, either as snow or as rain. There's a theory that says if we could create or put more condensation nuclei in clouds, we would get more precipitation out of it. This is known as cloud seeding. This is something a lot of people have talked about in the comments, something that we hear a lot about in emails and comments on YouTube and Facebook, and it's not something that could end the drought. While it does help in some circumstances, in some instances, and in really some locations, it doesn't work everywhere, and it doesn't actually provide a lot of extra snowfall. It can give anywhere from 3% more to 10% more snowfall. So say we get 5 inches of snow without cloud seeding, something that we might see with this incoming winter storm. Well, on a good day, if we cloud seeded that storm, not saying we would, but if we were to cloud seed that storm, maybe we end up getting 5.5 inches of snow. That would be 10% more. If we see a foot of snow, 12 inches on a good day, that would give us about 13.2 inches of snow. If we get 48 inches of snow without cloud seeding, on a good day with cloud seeding, that 10% more would bring us to almost 53 inches of snow. It is not a lot of difference. Now, every little bit helps, of course. SMUD, for instance, has been cloud seeding for quite a while, and they do it over a very specific area of the Sierra, and they don't do it for drought purposes. They do it for hydroelectric purposes, and it does help. They get 3 to 10% more when they seed, but it costs quite a bit of money. So it's not something we can do all the time with every storm, and you also need the perfect set of conditions to seed. You can't seed every storm. It's got to be just the right one. Ski areas do this, but again, it is not enough of a boost to bring us out of drought. It just simply is not something that we can do over a large enough area that gives us enough extra snow. Let's hear from the experts. Let's get to them. They can tell us even better about how cloud seeding works and why it won't actually bring us out of drought.
We are extracting moisture through cloud seeding, and there's no question about this. We also show that we are really not extracting a ton of snowfall or a ton of precipitation, and that's why this is one reason why we have had such a hard time really pinpointing it down over the last 20 years, because we cannot really produce a massive amount of snow. The idea behind cloud seeding is you have clouds that would naturally not precipitate or would naturally not produce precipitation. So specifically, we are targeting orographic wintertime clouds.
Katja Friedrich is a professor at the University of Colorado studying microphysical processes in clouds. This includes the study of cloud seeding.
So Idaho Power and Idaho, they are basically seeding the entire winter, and we would piggyback with our research instrumentation and say, okay, whenever they are seeding, we are basically monitoring the atmosphere and see how the silver iodide that they release in the aircraft, how does it actually mix in the cloud, glaciates the supercooled liquid, and how does it fall into the ground. And again, the idea was actually just to gather data that we can then use to put it in our numerical models. We were really fortunate that we actually had like 3 cases where we could unambiguously say that whatever we produced on that day, the precipitation or the snowfall, came from cloud seeding.
And Idaho Power isn't the only energy company using cloud seeding to generate electricity. One company right here at home has been cloud seeding for over 50 years to increase hydroelectric power.
SMUD's actually been doing cloud seeding since 1968. So we do this on an annual basis. It typically starts around mid-February. And the season varies, of course, depending upon the needs and the storms available. It typically goes till April, like I said, but it depends on the conditions and what the needs are.
If we're asking what the needs are, California needs water. So could cloud seeding be used to get us out of drought?
Yeah, I think that's the biggest question that I've been getting, especially lately. I've been getting it a lot, is can we cloud seed to solve the drought? SMUD only cloud seeds a very small area that serves our customers. It's a 400 square mile area up in the Upper American River watershed, specifically for the snowpack to melt into our reservoirs. So, if California or some larger, jurisdiction wanted to look at it, you'd have to combine multiple different, jurisdictions and agencies and locations and stuff like that. And I'm not quite sure what that looks like.
The biggest limitation to cloud seeding as a solution to drought is that it doesn't actually produce that much more precipitation. SMUD says they get an average of 3 to 10% more snowfall than without seeding. Still, they say that 1 additional inch of snowfall saves customers $1 million.
So again, there's not a lot of precipitation that you can generate from cloud seeding. Nevertheless, since all these states are in a really big drought and we really need the water, I think it is feasible because just to increase the snowpack. I think the different states are working pretty well together because they realize that this is not something that one state can tackle. They have to, because now what they're doing, they're seeding the higher terrain. So for instance, for the Colorado River, they're basically seeding in the higher terrain of the Colorado River. So you're basically accumulating the snowpack so that you have enough control of the water downstream.
Another problem with cloud seeding is that you can't seed every storm, everywhere, every time. It needs to have just the right conditions. A Goldilocks scenario, if you will.
Specifically, it has to be -4 degrees Celsius is the temperature that we're looking for to go up and seed clouds. Like I said, there's other factors, including, the wind direction, the pressure in the air, temperatures, which I just mentioned. All those things kind of go into, I guess I'm going to use the term perfect storm. We have to meet all those criteria for us to go up and seed clouds.
And with a warming climate, the perfect storm might be harder to come by.
How does cloud seeding changes in climate change? I think because now after our study came out, a lot of people got really excited because we now quantified this and we are able really to show that it is working. Right. On the other hand, we have to be careful because we can only cloud seed in a really small window, so it cannot be too cold or too warm. It has to be around this -5, -10 degrees Celsius, because otherwise this little iodide doesn't work. So the problem that we might actually encounter over the years as the winters get warmer, that it's getting too warm to cloud seed, and especially the way we are doing it currently. So it will be interesting to see how long we can actually do this. And since the winters are getting shorter, and also we don't really want to cloud seed during the rain events in the winter, because then we have the effect of rain on snow and we are creating these flooding. So it will be interesting how we can go forward in 5 or 10 years, because right now it's a hot topic and people are doing it, rightly so. But the question is that sustainable over the next 10 years?